Constant, linear, and polynomial function. We'll start first with a constant function. A function is constant if it's of the form f of x equals k, or we can also denote this as y equals k, where k is any real number. The domain, if you notice, there's no x in the equation, so that means x can be assigned with any real number, hence the domain would be all real numbers, and the resulting value of y, which is our range, is a value k. So the graph is a horizontal line at y equals k. This is an example of a constant function. So your x, if I would like to enumerate some ordered period, you can have, let's say, -1 and -2.75. We can have, let's say, 0.5 and -2.75. So we can assign any values of x, any real number, and the resulting value for y will always be 2.75. Hence, your domain, again, is a set of all real numbers, and your range is y equals to -2.75. So this will have a graph of a horizontal line at y equals -2.75. So for linear function, it's of the form ax plus b, where a and b can be any real number and a will not be 0. Because if a is 0, then this will just become our constant function. So we are familiar with an equation of line, and we know that we can substitute it with any real number that will also result to all the real numbers. Hence, your domain and range would be the set of all real numbers. So the graph is a line, and to draw the line, we just at least need 2 points to draw a line. So this is an example of a linear function where your a here is -2 and b here is 5. So for the domain and range, they are all set of real numbers. You can also write that in interval notation in this way. So this represents the set of all real numbers. So to graph, there are different ways to do this. So you can use any 2 points. So what we have here, this is what we call your y-intercept. So this is the value of y when x is 0. Okay. And this is also known as the x-intercept. That means this is the value of x when we set y to be 0. But aside from this, we can just assign any points. For example, we can also do assignments such as x is 0 and 1 and solve for y. So any of the assignment of x will do. So we have those 2 points, you plot those 2 points, and you connect, and you have your line. Next is a quadratic function. Quadratic function is the form ax squared plus bx plus c. Again, where a, b, and c are any real numbers, and a will not be equal to 0. Because if a would be 0, then we will be left with our linear function. So the quadratic function will have a graph of a parabola either opening upwards or downwards. Okay. For the domain, we can substitute x with any real number, hence domain will be the set of all real numbers. But for the range, since the graph is a parabola, you can see that there's always a limitation or a minimum or a maximum in the value of y. So if your parabola opens upwards, so how do we know if we have a parabola opening upwards? The value of a is positive. Okay, so that means in our range, we have this lowest value. Hence, this will be the range if your parabola is opening upwards. What does this expression represent? This would be the y value of your vertex, the y coordinate of your vertex. Okay, and if a is negative, your parabola will be opening downwards. Hence, we have this maximum value. Hence, the range is y less than or equal to -b squared minus 4ac over 4a. Now, what is this negative b over 2a? This negative b over 2a represent this is the vertex, that is the x coordinate. So there's an alternate way to solve for this y coordinate. If you want, you can solve for your x coordinate and evaluate that to the function. You should get the same value as this expression. So for our first example here, we have a quadratic equation wherein our a is 2 positive. So this is a parabola that opens upwards. For our domain, it will be the set of all real numbers. Since it's a parabola that opened upwards, then we have this minimum value. So this minimum value can be solved using this expression. So we just have to substitute the values of b, so negative 3 squared minus 4ac over 4 times a. So let's simplify this. So that would be 9 minus 8. So that's negative 1 over 8. So that would be the range. That also tells us that the vertex of our parabola, this vertex, this y coordinate is negative 1 over 8. Okay. For the x coordinate of the vertex, it's negative b over 2a. So if we substitute this, negative negative is positive, and 2 times 2 is 4. So this is the vertex of our parabola. How or when do we need to look for the vertex if we want to do a graph? Basically, it's enough to know, that's the most basic, no? Knowing the vertex of your parabola will already give us an idea of the graph. But if you want the graph to be more precise, then we would like to be able to solve for the what we call x and y intercepts of the parabola. Okay, so to solve for the x-intercept, we let y be 0. That means you have 0 equals 2x squared minus 3x plus 1. So you can either do factoring or quadratic equation or completing the square to solve for this. Here we have negative 1/2 and x is equal to 1/2 and 1. So what's the meaning of this? That means we have here the ordered paired 1/2 comma 0 and 1 comma 0. So these are your x-intercepts. Now, for your y-intercept, this is easier to solve because you just let x be 0. So in this case, you will just have y equals 1. So this is your y-intercept that is represented by this ordered pair. So to graph that, we just need all these points. So we have the points vertex, which is 3/4 and negative 1/8. The intercept, so we have our x-intercept, you have 1/2 comma 0, and then you also have 1 comma 0, and your y-intercept, which is 0 comma 1. So we're going to plot them. So here we have that's 0.75 and negative 1/2. Then we have 1/2 and 0. Okay. And then we have 0, 1. So since we know that it's a parabola opening upwards, so we just connect the following points. Then we have a better sketch of our graph. Okay, now, will you always have the x-intercept? No. So there are some examples wherein the parabola will not have your x-intercept. So when will this happen? So imagine if this is your parabola. Okay, let's say this is your parabola. Your vertex is here. So this is an example of a parabola with no x-intercept because you would not intersect the x-axis. Okay, so it's possible to have parabola with no x-intercept, but there will always be a y-intercept in our parabola. The graph will always intersect the y-axis. Next example, we have another quadratic function here. Here our a is -1, b is 2, c is 8. So since a is negative, we know that this is a parabola opening downwards. Then we know that the range, the y value, has a maximum value of negative b squared minus 4ac over 2a. So how do we solve for this? So we just, again, substitute the values b squared minus 4ac over 4 times a. So we're just going to simplify this expression here. So we have 4 plus 32. So that's 36 over -4. So that means your range is less than or equal to 9. Okay. Now, if we, for the domain, there's nothing to compute. The domain would be the set of all real numbers. To write this in interval form, this is -infinity to +infinity, and this would represent -infinity up to 9 in interval notation. So this will give us the vertex of our parabola. So the x coordinate would be negative of b, so -2 over 2 times a, -2. And then this we have computed at 9. So our vertex will be at 1, comma 9. So to help us graph, we would be looking for the x and y intercept. So let's write the equation again. Our function is negative x squared plus 2x plus 8. So to look for the x-intercept, we have to solve for the equation 0 equals negative x squared plus 2x minus 8. We can all write this on the left side so that negative becomes positive if you are more comfortable solving with a positive x squared. So let's see if this is factorable. Sorry, this is plus. So this is factorable. This is x minus 4 and x plus 2. So your x intercepts would be 4 comma 0 and 2 comma 0. So for your y-intercept, we let x be 0, so y is 8. So your y-intercept is 0 comma 8. So let's plot the points. We have 1, 9 for our vertex. Then we have 4, 0 and 2, 0. Sorry, -2, 0. And then the other one is 0, 8. So these are the points, and since we know that it's a parabola that will open downwards, okay, so we just connect these points. Okay. Then we have a parabola that will open downwards. So we have this intercepts, x and y intercept. Then the last one here is the polynomial function. So what is a polynomial function? It's a function wherein the exponents of this x or x, the exponent of the variable x are positive integers. So the constant, linear, and quadratic functions, they are also polynomial functions, but they have a more specific term, when we have a more specific graph like the constant, linear, and quadratic, but they are all considered a polynomial function. So these are examples of polynomial functions. So I have your examples wherein the degree of the polynomial is 3 and here 4. So you would see that the domain will be all real numbers, but the range will depend on the graph. So at this first graph, you can see clearly that y can be any real numbers, but for the second one, there's a minimum value. So it's not easy to do the graph of the polynomial function without calculus. So we just have to learn how to find the domain and the range. So here is the summary of what different functions we discuss. You have your constant, y equals k, or f of x equals k. The graph is a horizontal line. Then you have your linear, your domain and range are all real numbers. Your graph is a line with a positive or a negative slope. Okay, then for the quadratic function, it can be either when a is positive, you have a parabola opening upwards. When a is negative, you have a parabola that open downwards, and that will affect our domain, our range of the function. Okay, and then you have the last, the polynomial functions.